right, this is worksheet 5.1, day 2. This is the second part. We're supposed to find any relative extrema points of inflection. So to do that, we take the derivative. So that's going to be 2x over 2. So x minus 1 over x. That's our first derivative. We're going to set that equal to 0. And if I add that 1 over x over and multiply, I get x squared equal to 1. So that means x could equal positive or negative 1. Those are our critical points. Okay? So if I go ahead and test negative 1, 1, go back to the first derivative. If I were to put, say, 1/2 in, I get 1/2 minus 2. That'd be a negative. All right, so I'm going to get a negative inside of that range there. If I were to put, I'm sorry, I do apologize. There is another critical point at 0 because that's where the derivative is undefined. So I technically should have something at 0 there. Okay. We'll see if it matters in just a second. All right, so if I put 1/2 in, I got a negative. If I put negative 1/2 in, I get negative 1/2 minus negative 2, which does turn positive, so that did matter. All right, so it's an undefined at 0, but we do have a switch there. Okay, if I could pick something like negative 10, I put that in, I get negative 10 minus a negative 1/10. That's going to be negative. If I put something positive like 10 in there, I get 10 minus 1/10. That's a positive. All right, so the derivative switches from negative to positive to negative to positive. So we have a relative minimum here at negative 1 and at positive 1. And then we have a relative maximum at 0. So relative minimum, x equal negative 1, positive 1, relative max at x equals 0. And that's going to be tricky to say. Again, that 0 was kind of not so obvious, right, because of that. But that's what's going on there. All right, as far as the points of inflection, we're going to do the second derivative now, which will give us 1 minus, and then if I make that x to the negative 1, it's going to be a negative 1, so positive x to the negative 2, or 1 over x squared. Okay, now if I set that equal to 0, and subtract 1, or just maybe move this over and divide, what I end up with is x squared equals negative 1, and there is no solution to that, right? So because there's no solution, there are no values that would make this equal 0, and so therefore there are no points of inflection. Okay. So I found the second derivative. It just happens that we don't have anything to solve it out. So we'd have to kind of go back and kind of look again and see. Now, one of the things that I'm noticing too as I look at this is I can't, because it's not natural log of absolute value, it's just natural log of x, this implies that x is actually greater than 0. So it's not that any of this work is bad, and if you have it, it's good, you know, it's not wrong, but when we're going back, I can't do natural log of negative numbers and I can't do natural log of 0. So really, all of this is kind of worthless. So really we only end up with one thing. So I take this back. We only end up with relative minimum at 1. So the graph's probably going to decrease and then increase. It'll be concave up the whole time. That's why we have no points of inflection. All right. A little bit on the tricky side there. Come here, same idea. Natural log of x over 4. X has got to be greater than 0. So we'll kind of keep that in mind as we go. Let's do the first derivative, dy dx. This is a product rule. It's going to be 2x natural log of x over 4 plus x squared times the derivative of this, which is 1 over x over 4. So that's going to be 4 over x if we flip it, times the derivative, which is 1/4. So that actually cancels out. This cancels out as well. We get 2x natural log of x over 4 plus x. Okay, now I can pull an x out of that, and I end up with this right here. So this is what I'm setting equal to 0. So that tells me x could equal 0, but we already know that it can't. It's got to be greater than 0. So that kind of goes away. We end up with just this right here, this 2 natural log of x over 4 plus 1. We want to know when that equals 0. So if I subtract 1 and divide by 2, I end up with this right here. If I raise it to a power of e, and then if I multiply by 4, I get 4 times e to the negative 1/2. That's our critical point. All right? So I want to know if that's a relative minimum or maximum. So if I put that in here, boy, that's going to be really difficult to know, you know, what's happening. So e by itself is about 3. If I take the square root of that, I get about 1.7. The negative means it's going to the bottom. So 4 divided by about 1.7 would give me about 2 point something. So if I tried 1 should be over on this side. If I tried 10 should be over here. This is going to be something between them. Would that be, did they give you something that difficult on the AP? Probably not. But let's go ahead and try this here. So if I go back to the derivative, all right, which is, well, I can go to this one here, put 1 in. I get 2 times natural log of 1/4. That's a negative value. Plus 1. This is going to end up being negative here. Okay. Then if I put something bigger than that in here, I'm going to end up getting a positive. So that we have a relative minimum at x equal 4e to the negative 1/2. Okay. Now, as far as the second derivative goes, if I do that on this one, I'm going to have 2 natural log of x over 4 plus 2x times 4 over x times 1/4, and then plus the derivative of x, which is 1. All right, this all cancels here. That cancels. I end up actually with 2 plus 1. So this is 2 natural log of x over 4 plus 3 is what we end up with. Okay, let's set that equal to 0. Subtract 3 divided by 2. Raise it to the power of e, and multiply by 4. We end up with this right here. Okay, so that's our possible point of inflection. So square root of e again is about 1.7. If you take it to the third power, you're going to end up with, well, maybe it's easier. So something 3 to the third power is 27 squared. That's going to be a little under 5. Negative puts it down below, so we're going to have about 4/5. So in my mind, I'm thinking this is about 4/5. Okay. So if I put that here, I'm going to pick something a little bit bigger, say, you know, maybe 10. If I go back to the derivative, put that in, natural log of 10 over 4, that's going to be a positive, plus 3 is going to be positive. This is going to be a positive here. If I pick something a little less than that, put it in, this is going to be very negative. I'm going to have a negative there. So I do have a point of inflection at x equal 4e to the negative 3/2. Okay. Again, this is a pretty nasty one. Right? If you can get through that and feel okay, that's really good, but most of us are probably going to struggle with something like that. So I want you just to see it and say, does that make kind of sense? Do you understand how to get from step to step? Maybe you didn't do it, but if it makes sense to what I did, then that's all right. All right, let's go ahead and do the last page here. This is implicit differentiation. We're trying to find equation of a tangent here. So I've got point and I've got slope. As far as the point goes, 1, we know we got to put 1 in and see what y equals. So if I put 1 in, I get 1 minus 5 natural log y plus 2y cubed equals 8. All right, if I were to subtract that, I get negative 5 natural log of y plus 2y cubed equals 7. Okay, now at this point, I really don't know anything algebraically that would help us do that. All right, we're going to have to use a calculator. So I'm going to grab a calculator, and I'm going to go to y equal and put a negative 5 natural log of x plus 2x cubed. All right, and then put in a line at 7. I want to see where those intersect. Okay, so I hit graph. All right, and once I have that, I'm going to go ahead and hit intersect, enter, enter, enter. And I get an intersection at 0.248. Okay. Now again, the AP is probably not going to give you something quite this day. It would probably be something where you could find that y value on your own. But regardless, this is what we end up with right there. All right, so now let's go ahead and take the derivative. This is going to be 4x cubed minus 5 times 1 over y times dy dx plus 6y squared times dy dx equals 8. Okay, now this is where I would tell you normally to put your point in and see what you get. And not that that's a bad idea here, but You may want to just put maybe the 1 in for now, leave the y, and then put the y. I don't know. This is kind of, like I said, a nasty looking problem here. So let's just go ahead and put it in and see what we get. So if I put the 1 in, I get 4 times 1 cubed 4 minus 5 divided by 0.248. So if I do that, I get 20.161 dy dx. Okay, plus now I'm going to do 6 times 0.248 squared, and that's 0.369 dy dx equals 8. If I do negative 20.161 minus 0.369, I get a negative 20.53 dy dx equals 8 minus 4, which is 4. Go 4 divided by that. And like I said, this is a pretty messed up one. Dy dx is a negative 0.195. That's our slope. Put it all together, y minus 0.248 equals negative 0.195 times x minus 1. Okay, that's it all worked out. But we had to use the calculator to kind of work through it and stuff. That's how we do it. This one gives us the point. We just have to find the slope. So we're going to take the derivative of natural log xy. That's 1 over xy times the derivative, which is a product rule. Should come out like that. Okay, plus 2y times dy dx equals derivative of 2, which is 0. Okay, let's put our e and 1 in. This is going to be 1 over e times 1 plus e dy dx plus 2 dy dx equals 0. Now I'm going to distribute this. That gives us 1 over e plus 1 dy dx plus 2 dy dx equals 0. So if I subtract that and put these together, I get 3 dy dx equals 1 over e, and then if I divide, I get dy dx equal to 1 over 3e. Okay. Now I can use that point, y minus y equals slope times x minus x. And there we go. Okay. So pretty tricky on the last parts there. Don't get panicked if you weren't sure, but more importantly, can you follow the logic and see it?